Hello, welcome to week 5. We're going to be starting our second week of electromagnetism. We'll be talking about electromagnetic devices, electromagnetic induction, generators, transformers, and the electrical grid. We're going to start off with electromagnetic devices. So in this next picture, there's a little boy on the left pressing the doorbell on his playhouse. The doorbell is connected to a battery, so it actually rings when he pushes the button. The little girl on the right is using a handheld fan to cool off on a hot day. The fan is also battery operated, and the blades of the fan turn in a blur of motion. What do the doorbell and the fan have in common? Well, as you probably guessed, both of them work because they contain electromagnets. Many common electronic devices contain electromagnets. An electromagnet is a coil of wire wrapped around a bar of iron or other ferromagnetic material. When the electric current flows through the wire, it causes the coil and iron bar to become magnetized. An electromagnet has both a north and south magnetic pole and a magnetic field. Turning off the currents turns off the electromagnet. To understand how electromagnets are used in electronic devices, we'll focus on two common devices, doorbells and electric motors like the one that turns the blades of a fan. So I have a question for you. Besides doorbells and fans, what are some other devices that contain electromagnets? Take a moment and think about it. The answer is any device that has an electric motor contains electromagnets. Some other examples include hair dryers, CD players, power drills, electric saws, and electric mixers. This is a simple doorbell. Like most doorbells, it has a button located by the front door. Pressing the button causes two electric contacts to come together and complete an electric circuit. In other words, the button is a switch. The circuit is also connected to a source of current, an electromagnet, and a clapper that strikes a bell. We're going to watch a short video clip that explains how this happens.
In the last video, we saw what an electromagnet is. Any conductor such as a straight wire through which electric current is flowing is an electromagnet. Because there's a magnetic field around it. However, we can make the magnet strong by wrapping the wire around a piece of iron, such as an iron nail. Even if the current is the same in both cases, this one will result in a stronger magnetic field. Now, there are some factors on which the strength of the electromagnet depends. The current flowing in the wire is one of them. If we increase the flow of the current in the wire, the strength of the magnetic field of this electromagnet will also increase. Is there any other way? Yes, there is. Another way to increase the strength of this magnetic field is by increasing the number of turns of the wire around the nail. More the number of turns, stronger the magnetic field will be. We will learn about these factors in much more detail in our higher grade. In this video, we will see a few applications of electromagnet. So, where do we use them? You must have seen large machines used to lift up cars. They have an electromagnet in them. This electromagnet is so strong that it can lift the whole weight of the car. Electromagnets are also used to separate metal objects from a pile of junk. Now, what if I tell you that they are used in the fastest trains around the world? Yes, the Shanghai Maglev train is studied as the world's fastest train, and it works on the concept of electromagnetism. Understand the use of electromagnets in simple devices such as electric bells. Yes, most of the bells we see nowadays are electric bells. Here's a very simplistic diagram of an electric bell. Thirdly, why is it not complete? Well, we haven't pressed the switch yet. When we push the button, the circuit gets completed and the current flows from the positive to the negative terminal. But when the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts the soft iron towards it. Notice what happens when the striker hits the ground. As soon as the soft iron is shifted away from its original spot, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue after the switch is opened again.
Okay, so question. What happens when current flows through the doorbell circuit? The electromagnet turns on, and its magnetic field attracts the clapper. This causes the clapper to hit the bell, making it ring. Because the clapper is part of the circuit, when it moves to strike the bell, it breaks the circuit. Without current flowing through the circuit, the electromagnet turns off, and the clapper returns to its original position. When the clapper moves back to its original position, this closes the circuit again and turns the electromagnet back on. The electromagnet again attracts the clapper, which hits the bell once more. And this sequence of events keeps repeating over and over and over. So how can you stop the sequence of events so the doorbell will stop ringing? You guessed it, stop pressing the button. This interrupts the circuit so no current can flow through it. Let's talk about electric motors now. An electric motor is a device that uses an electromagnet to change electrical energy into kinetic energy. This is a simple diagram of an electric motor. The motor contains an electromagnet that is connected to a shaft. When current flows through the motor, the electromagnet rotates, causing the shaft to rotate as well. The rotating shaft moves other parts of the device. For example, in an electric fan, the rotating shaft turns the blades of the fan. Why does the motor's electromagnet rotate? Think about it for a moment. What would cause the motor's electromagnet to rotate? Well, the electromagnet is located between the north and south poles of two permanent magnets. When the current flows through the electromagnet, it becomes magnetized, and its poles are repelled by the like poles of the permanent magnets. This causes the electromagnet to rotate toward the unlike poles of the permanent magnets. A device called a communicator then changes the direction of the current so the poles of the electromagnet are reversed. The reversed poles are again repelled by the poles of the permanent magnets, which have not reversed. This causes the electromagnet to continue to rotate. And these events keep repeating, so the electromagnet rotates continuously. Let's summarize. Electromagnetic devices are devices that contain electromagnets. That sounds simple enough. Examples of electromagnetic devices include doorbells and any devices that have electric motors, such as electric fans. As you look around your house, please notice any devices that are electromagnetic devices. You will know that it will be an electromagnetic device if it has plugged in to be used. For example, a drill, a blender, or many other devices that have to be plugged in to be used. Once it's plugged in, there should be a motion related to plugging that device in. Then you know for sure there's an electromagnetic device inside that device. Is a toaster an electromagnetic device? No, a toaster is not an electromagnetic device. Yes, you have to plug it in, but there's no motion. What about a radio? Is a radio an electromagnetic device? Yes, a radio is actually an electromagnetic device, even though you don't see the motion that's taking place. The speakers on a radio move, which turn electrical impulses into sound. So even though you don't see the motion, it does have an electromagnet inside of it. The electromagnet in a doorbell attracts the clapper, which hits the bell and makes it ring. An electric motor is a device that uses an electromagnet to change the electrical energy to kinetic energy. When current flows through the motor, the electromagnet rotates, causing a shaft to rotate as well. The rotating shaft moves other parts of the device. I hope you enjoyed our overview of electromagnetic devices, and we will talk again soon. Thank you so much. Have a wonderful day.